If you ever think of buying good quality meat at unbeatable price, think Magilac Butchers, your only suitable solution for quality meat for you and your family consumption. Our comprehensive range of meat products include minced meat, beef slices, topside, knuckle, strip loin, and forequarter. We offer consistent value, quality, and service through animals grass-fed and bred, especially for their meat. This makes and easy to cook. All meats at Magilac Butchers are halal, including for the first time in the Gambia, the new Mongolian whole lamb, available only at Magilac Butchers. Magilac Butchers on Caraba Avenue, opposite the Petrogas petrol station traffic lights. For inquiries and orders, please call 7688-688. 7688-688. Magilac Butchers, the home of quality meat and chicken products at unbeatable prices. If you ever think of buying good quality meat at unbeatable price, think Magilac Butchers, your only suitable solution for quality meat for you and your family consumption. Our comprehensive range of meat products include minced meat, beef slices, topside, knuckle, tenderloin, strip loin, and forequarter. We offer consistent value, quality, and service through animals grass-fed and bred, especially for their meat. This makes tender and easy to cook. All meats at Magilac Butchers are halal, including for the first time in the Gambia, the new Mongolian whole lamb, available only at Magilac Butchers. Visit Magilac Butchers on Caraba Avenue, opposite the Petrogas petrol station traffic lights. For inquiries and orders, please call 7688-688. That is 7688-688. Magilac Butchers, the home of quality meat and chicken products at unbeatable prices. If you ever think of buying good quality meat at unbeatable price, think Magilac Butchers.
The last time he sent the money, it was not enough to buy all the provisions.
Oh, sorry, I forgot to tell him.
Are you guys talking about money transfer to buy provisions?
Yes.
But
Don't you know about Baluwo?
Baluwo? What is Baluwo?
Baluwo is a service that your son can use to send provisions directly to you guys from the shop. And you don't have to worry about the exchange rate.
Tell me how Baluwo works.
It's very simple.
Just log on to baluwo.com and shop, or download the app on your phone. You can shop on the website or using the app to buy online basic products for your family and friends. With Baluwo, you decide what your money is spent on. Your money, your choice. Buy online products for your family and friends in the Gambia, Senegal, Nigeria or Mali. Baluwo, better than sending money.
Hi, my name is Buba Gajigo and you're watching Kerr Fatou. This is your educational program, and now we're gonna bring you lessons from senior school. If you have your kid attending senior school, get them prepared, and I hope you enjoy these lessons.
Are you thinking of owning your dream homes? EJ Investment is here for you. Secure our quality bungalows with 2, 3 or 4 bedrooms, or our story buildings 3 or 4 to 5 bedrooms at very affordable prices with flexible payment plans at our Sanyang Seaview Estate, where you can enjoy the cool breeze with modern infrastructure such as Tarot's covered drainage system, modern electrification with street lights, gated entrance with security posts, and social amenities such as gas station, shopping mall, medical clinic, park, schools, children daycare, and a lot more. Our dedicated team of professionals will keep the estate clean at all times, provide security and patrol team within the estate premises, install latest technologies such as CCTV, Wi-Fi, home network installation, solar panel, and power backup system. Also, check out for our additional home facilities and interior design service such as premium tiling, wall plaster, home landscape, fingerprint home lock, and a lot more. Visit our office at Senegambia Kololi Highway and get a free site visit tour, or contact us on 4464838. WhatsApp us on 3259220. Or you can visit our Facebook page or Instagram on EJ Investments. EJ Investments, we are first in properties.
Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
Hi everyone, I am Mr. Babukar Au, your chemistry tutor, and our 3 lesson will be based on covalent bonding. So our previous class we were discussing about types of chemical bonding, and then we generally talk of the ionic bond formation and also ionic compounds with their respective properties. Today we will be discussing about covalent bonding. We said ionic bonding, that is the previous class, we said ionic bonding will take place whenever a metal tends to donate its valence electron and the non-metal also will accept. They will form opposite charges, and they are strong electrostatic force of attraction between these opposite charges, and which will result in the formation of a stable compound or molecule called ionic compound. Now today we'll be discussing about covalent bonding. And then this is the bond that generally takes place between non-metals. We said non-metals can receive electrons. They can gain electrons. That's their main property. So, when we have two or more non-metals combining together, how are they going to react? Or how are they going to bond? If they can just accept or receive electrons. Now, in this kind of bond, we will come to realize that the non-metals will share electrons. They will share electrons. That is, we will have something like this. Something like this. Now, this space where the sharing of electrons occurs is called electron cloud. Electron cloud. So, any electrons that are contained inside this electron cloud now, for example, we have two here. Now, they will be called bond electrons or shared electrons. So now if we have other electrons outside that are not actually located inside this electron cloud now, they will be called lone pairs. Lone pairs. And now the definition of bonding rates. This involves unequal sharing of electron pairs between bonded atoms to form molecules. That is, if A and B wanted to react and then the bond is covalent, then they will share electrons, and the shared electrons will be put in the in the electron cloud. Now, covalent bonding takes place between non-metals. This kind of bond can only take place in non-metals. There is no loss or gain of electrons. You cannot say this non-metal must donate and the other non-metal will accept. No, there is no gain or loss of electron in this kind of bonding. The reacting atoms contribute equal number of electrons to form the bond. Now, atom X and atom Y now, we assume this is their electron cloud. If atom X puts 2 electrons here, Y also must put 2 electrons. So they need to bring equal number of electrons as far as sharing is taking place. So each of X and Y needs to bring equal number of electrons. Covalent bonds within molecules are stronger, but the forces between them are weaker and can easily be broken. Now, for example, if we have H2O, water. Now, when we draw this water now, we draw the molecule. When you draw the molecule of water, you will have something like this. Something like this. Something like this, huh? Now, you find out that there will be sharing of electron here, and there is sharing of electron in this case. So now, it said that the bond inside the molecule of water is stronger than the bond between two molecules of of water. That is, there will be there can be bond between one molecule of water to another molecule of water. But these bondings are not are not strong. This is why when you boil water now, you see that the state of matter of the water will change from liquid to gas. But it doesn't mean that the bond between the hydrogen and the oxygen is breaking. No. But the bond between one molecule of water with another molecule of water will tend to break, and then the state of matter of this water will change from liquid to gas. A pair of shared electrons is called a shared pair or bond electrons. That is the shared the shared pair here. A pair of unshared electron is called lone pair. Lone pair. And also a lone pair of electrons play an important role in influencing the shape of the of the molecule. Now you see, the shape of water is something like V shape, because the lone pair electrons here are influencing the shape of the water. So we have VSEPR theory, and this theory now is telling us that lone pair electrons and bond electron, they always what? Repel one another, and that will help in the changing or in saving of what? Of molecules. Now a covalent bond in which one pair of electrons is shared is called a single covalent bond. A single covalent bond. For example, now chlorine gas. If you have chlorine gas, or if you have hydrogen chloride, that is HCl. So you'll have two molecules like this. You can have Cl, you can have Cl, two atoms of Cl. The valency of this is 7, and the valency of this is 7. So you'll have here 1, 2, 3, 4, 5, 6. So we have one more from this place. Here we'll have 1, 2, 3, 4, 5, 6. We have one more from this place. So this needs 2 to be stable. This needs what? 2 to be stable. If you added this one there, then it means it will need 1. If you add this one to this one, it will also need what? 1 to be stable. So this atom now will put this electron to this place, and this one also will bring this electron to this place. So they will share in what? This pair of what? Electrons. So now this electron now belongs to both this chlorine and this chlorine atom. Do you understand? And now in this case we have what? A single covalent bond. And a single covalent bond is a bond where you have what? A pair of electrons is what? Is shared. That is 2 electrons. And then we can simply represent it by using what? A single what? Line. 2 pairs of electrons are shared is called a double covalent bond. For example, we have oxygen gas. Now we can have O, we can have what? O. So oxygen is having a valence of 6. This atom also is having a valence of 6. So here we'll have 1, 2, 3, 4. 2 more. 1, 2, 3, 4. And here we have what? 2 more. So you see now, if you put these 2 here, this will need 2 more to be stable. If you put these 2 here, this will need 2 more to be what? To be stable. So now we have 1, 2, 3, 4. 1, 2, 3, 4. For each of these atoms of what? Oxygen. So this oxygen now needs 4 more to be stable. This one also needs 4 more to be stable. While this one is having 2 assets, this one also is having 2 assets. So what these 2 atoms are going to do is, these atoms will bring its 2 electrons on this side. This one also will bring its 2 electrons on this side. So at the end, you'll have 4 electrons, 2 pairs. That will be what? Shared between what? These 2 atoms of oxygen. And here we have 1, 2, we represent what? A bond. 1, 2 also we represent what? A single bond. That's why we say this is called what? A double covalent bond. A double covalent bond. Again, 3 pairs of electrons are shared, or a covalent bond in which 3 pairs of electrons are shared is called triple covalent bond. For example, we have nitrogen molecule. Nitrogen molecule. So here we have N. Here also we have what? N. So this N has a valency of 5, and this N also has a valency of what? 5. So this one now we'll put here 1, 2, and this one also will put here what? 1, 2. So this has 3 more. This one also is having what? 3 more. So if you put these 3 electrons on this side, it means this nitrogen will need 3 more electrons to be stable. You add these 3 here, this one also will still need what? 3 more electrons to be what? To be stable. So what these 2 atoms will do is, this one will bring 1, 2, 3 electrons. That is these 3 electrons on this side, and this atom also will bring 1, 2, and 3 electrons on the what? On the other side. So at the end, they will share what? 6 electrons, and these are called what? 3 pairs. Because 1, 2 pair, 1, 2 pair, 1, 2 pair. So at the end we have what? 3 pairs of what? Electrons. And this is called what? Triple covalent bond. Because each pair of electrons represent what? A bond. And then we represent the bond using what? A dash. Now we have Lewis structures. This is an example of what? Of the Lewis structure. Of the Lewis structure. Huh? Yes. You can use this model also to represent covalent bonds. Lewis structures. Huh? Now Lewis structures are diagrams that show valence electrons as what? Dots. We just use what? Dots to indicate what? the valence electrons that are found in these atoms. Lewis structures are also known as Lewis dot or electron dot diagrams. Electron dot diagrams. And here we have different kind of elements in the periodic table. And then we use the Lewis dot structure to represent their valence electron. Now you can see this periodic table where you have at this period 1, hydrogen and helium. And hydrogen is having a valency of 1 and helium is having a valency of 2. If you move down to period 3, where you have sodium, single valency, you have magnesium, valency of 2, you see it's indicated using what? 2 dots. Also you have phosphorus, which is having a valency of 5 and it is indicated using 5 dots. Now we have some sample questions here. And the first question reads, that is number 4, how many valence electrons does nitrogen have? How many valence electrons does nitrogen have? That is, you can simply say nitrogen is what? Atomic number 7. And here, the old electron configuration will have something like 2 and what? 5. It means the valence electron here, we can know it by using what? The number of electrons in the last what? Cell. And these questions, the first option is A, which says 2. The second option is B, which is 3. And option C says 4. And option D says 5. Which means the correct answer here is 5. Because we have 5 electrons in the last cell. Now number 5 reads, the Lewis structure for nitrogen is. Now, in this case, we need to count the number of dots on nitrogen. And those dots represent what? The valence of nitrogen itself. Now we have 1, 2, that is 2 on top. We have 3, 4, 5. That is the valence electron of nitrogen is 5, which is true, which means here the correct one here is true. We now also have single covalent bonds. Single covalent bond. And this is the way we represent single covalent bond. And then I will give another example using the other method, not Lewis. That the same one. In this case now, I can put here, I'll use this as my what? Chlorine. And here also I put what? Another what? Chlorine. Here I'm just trying to draw what? The last cell. That is the valence cell. This chlorine now constitutes of 7 valence, 7 what? Valence. And they share 2 electrons, which means this chlorine will bring here 1. And this chlorine also will bring 1. So I'll use different symbol for this chlorine atom. Something like this, dot, for this chlorine. So it means we have 6 more. We also have 6 more here. Because this one uses 1 here, and this one also uses 1 here. We have 6 more, 6 more. So here we'll have 1, 2, 3, 4, 5, 6. For this, here also we have 1, 2, 3, 4, 5, and 6. At the end, if you count, you will have 1, 2, 3, 4, 5, 6, 7, 8, which is octet structure. You also have 1, 2, 3, 4, 5, 6, 7, 8, which also octet structure. So in this case, we have what? A stable molecule. A stable molecule. Now, a single covalent bond, that is oxygen, needs 2 electrons to complete its outer shell. For example, we want to show the bond that is taking place in water, that is H2O. H2O. Now I can say we have here H plus the oxygen now, and in this case this will give us what? H2O. Now the valency of hydrogen is 1. We just show it by using what? A single dot. The valency of oxygen, that is the valency electron of oxygen now, is 6. We have 1, 2, 3, 4, 5, 6. So you see now, this hydrogen atom now is reacting with oxygen. But oxygen needs 2 electrons to complete its what? Electron configuration. While hydrogen now needs to what? Bond with this oxygen by just what? Using a single electron. So 1 electron from this hydrogen atom now cannot satisfy 1 atom of oxygen. So therefore now hydrogen will come with what? With 2 different atoms. Now we can draw this using the other model. That is, we'll have this for hydrogen, but this is 2 atoms plus we have what? Oxygen, which is having 1, 2, 3, 4, 5, 6. Now, when they react now, this oxygen now will be what? The parent atom, like this, and then we'll attach 2 atoms of what? Hydrogen to it. One will come to this side, and the other one will come to this side. So, these are hydrogen atoms, and this is the what? Oxygen atom. So, hydrogen can only bond using a single electron. So, this hydrogen now will use 1 electron here, that is in the electron cloud. Oxygen also will bring 1. Hydrogen will bring 1. Oxygen also will bring 1 electron. So at the end, oxygen will use here 1, 2. So 1, 2, out of the what? 6, we'll have 4 more. So we'll have here 1, 2, 3, and then 4. If you count now for the oxygen, you'll have 1, 2, 3, 4, 5, 6, 7, 8, which means the oxygen is stable. 1, 2 for the hydrogen duplet structure stable. 1, 2 for this hydrogen duplet structure, which is also stable. Now we can simply show this thing using what? Another model, that is, you have oxygen, single bond, hydrogen, single bond, hydrogen. 2 what? Lone pair of what? Of electrons. So these single electrons are both representing what? 2 electrons. Now the same thing you can try NH what? 3. And in the NH3 now, we'll have hydrogen atoms as what? Single valence plus nitrogen, we'll have 1, 2, 3, 4, 5. And now in this case, they will form NH3, which means we need 3 atoms of what? Hydrogen. So you can follow these steps, and then you'll be able to draw what? The structure of what? Nitrogen molecule. Now, a Lewis dot structure will commonly represent the covalent bonds by what? Dash. That is this lines. This lines. See, the bonds are represented by using what? Using dash. And each dash represents what? A pair of electrons. Now, a pair of valence electrons that is not shared between atoms is called an unshared what? Pair. Unshared pair. Like these ones. These are the what? Unshared what? Unshared pairs. Also known as what? Lone pair of electron or non-bonding pairs. Now we have a question again, which reads, how many electrons are shared by 2 atoms to create a single bond? How many electrons are shared by 2 atoms to create a single bond? And the correct answer is 2 electrons, because a pair of electrons will represent a single bond. Now we have methods of drawing Lewis structures. Methods of drawing Lewis structures. And here also, I'll guide by drawing one structure, and then the rest of the samples you can try them. Phosphorus chloride. Phosphorus chloride. Now in this case, see, this molecule now constitutes of what? Phosphorus. And phosphorus is what? 15. And again, it constitutes of what? Chlorine. And chlorine is what? 17. The electron configuration of phosphorus is going to be 2, 8, 5. 2 plus 8, we have 10. 10 plus 5, we have 15. And then this chlorine now will be 2, 8, 7. 2 plus 8, we have 10. 10 plus 7, we have 17. So, phosphorus needs to bond with what? With chlorine. The valency of phosphorus is 3, which means phosphorus needs 3 more electrons. Do you understand? The valency of chlorine in this case is 1, which means chlorine needs 1 more electron to be what? Stable. They are bonded, and this can only bond with this using what? A single electron. So therefore now, chlorine must come with what? 3 atoms, because the phosphorus needs 3 more electrons, and each atom of chlorine is having what? A single electron. Therefore, the chlorine atom or the chlorine must come with what? 3 different atoms. So that each atom now will give the phosphorus a single electron. At the end, you can have what? A stable electron configuration. Again, we can say P The valence electron now here is 5. You can have here 1, 2, 3, 4, 5. We can also have chlorine, Cl, and then the valence electrons are what? 7. We'll have 1, 2, 3, 4, 5, 6, and then what? 7. But we need 3 atoms. Therefore, we'll have what? 3 atoms of chlorine. So, this phosphorus now will be something like this. P, we have here 1, 2, 3, 4, and what? 5. So, each of these electron needs to be what? Paired, so that it will be stable. And we have chlorine now. So, one chlorine atom now will come to this side. You see? There was 1 electron here, so 1 from the what? Chlorine. So, we have 2 above, we have 1, 2, we have 1, 2. Another chlorine will come to this side. See? And then it will bring the first electron to this side. And then we'll have 1, 2, 3, 4, 5, 6, plus this one, 7. And the other chlorine now will come to this side. Cl, where you have another electron from this chlorine. You'll have 1, 2, 3, 4, 5, 6, and this as 7. Now you see at the end now we have what? A stable what? Structure, that is a Lewis dot structure from this phosphorus and what? And chlorine. Now here we have phosphorus has an electronegativity of 2.1 and chlorine has an electronegativity of 3.0. That is, phosphorus is 2.1 and chlorine is 3.0. So we need to subtract these two. If you subtract 3.0 with 2.1 now, you will have 9.0. And 9.0 now is less than what? 1.7. Which means now this molecule or compound now is more what? Covalent. It's more covalent than what? Than ionic. It's more covalent than ionic. And then you see these bonds can be represented as, you can have P, single bond chlorine, single bond chlorine, single bond chlorine. And here you have what? 2 lone pair electrons. And then you'll have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have single, single, single bond. So this is single covalent bond. Factors influencing covalent bond formation. Just like the factors that influence the formation of ionic compounds or ionic bond formation, we also have factors that influence the covalent bond formation. And one is electron affinity. Now, the higher the electron affinity of the non-metals, the stronger the covalent bond. So now here, the higher the affinity of the non-metal, the higher the affinity for the non-metal towards electrons. So when this kind of non-metals bond, they tend to form what? A stronger covalent compound compared to the non-metals that have what? Low affinity. So whenever non-metals with high affinity forms a compound, now their compounds will be what? More stronger than when non-metals with low affinity combine to form a compound. We also have ionization energy. The higher the ionization energy of the non-metal, the stronger the covalent bond form. Again also, if you want to remove an electron from the non-metal and then you need huge amount of energy, it means that kind of non-metal now, when it tends to form a covalent compound now, the covalent compound becomes what? A very, very strong. That because the ionization energy needed there is what? Is very, very high compared to the non-metals that you need least amount of energy to remove electron from them. And the third one is electronegativity difference. That is, the lower the electronegativity difference between the atoms, the stronger the covalent what? Bond form. That is, in this case, we calculate now, and then we have something like 0.9. And this 0.9 cannot be compared to this 1.7. Because it is far smaller than what? 1.7. It means this compound now, it's more covalent than what? Than ionic. If we calculate, and then maybe we have something like 1.7 or more than 1.7, then we will rule out this molecule from what? The covalent compounds. Therefore, it will be what? An ionic what? Compound. But because we have something smaller than 1.7, that's why we say this compound or this molecule is what? Is covalent. So the smaller the value between the reacting non-metals, the stronger the covalent bond. That's why we said a true covalent bond can be only achieved when atoms of the same element react. Like if you have oxygen gas, this reaction involves oxygen and what? And oxygen. If this oxygen is 3.0, this also is going to be what? 3.0. So if you subtract them, you'll have what? 0. Which means this is going to be what? A true covalent bond. If you have Cl2, this Cl can be what? You have Cl and what? And Cl. If this Cl now, for maybe it is 3.5 and this one also is 3.5 now. If you subtract them, you still have what? 0. So the difference between this and this is 0, which means this Cl2 now is a true covalent what? Bond. Whenever there is a slight difference between these two combined atoms now, there will be what? Polarity in this molecule. That is, we have some covalent compounds are what? Are polars, because there is what? Difference between the combining atoms. As far as you need to form a pure covalent molecule or compound, the difference between two atoms should be 0. Now we have practice question. That is, we also have Cl2. Practice question. You can practice them also. We also have methane. You can practice this one also, methane, because we know methane consists of carbon and 4 atoms of hydrogen. You can simply draw these bonds. Which element in water is the least electronegative? A. Hydrogen. B. Oxygen. C. The electronegativities are equal. C is not correct, because oxygen and hydrogen are not the same. They are atoms of different elements, which means their values cannot be the same. Only atoms of the same element will tend to have the same electronegativity values. Now, in this case now, the one with the least electronegative is hydrogen, which means A is the correct option. How many total valence electrons does water have? How many total valence electrons does water have? Now, if you draw the structure of water now, you find out that all the valence electrons, after drawing now, will be in what? In the oxygen atom itself. And therefore, the number of electrons in the what? In the oxygen atom now will be what? The valence electron for this water. Of course, it will include what? The hydrogen, because the hydrogen atoms are attached to the what? Oxygen atom. At the end, your correct answer there will be what? 8. You can draw the molecule and then you compare your answer to what? To 8. The correct answer should be 8. That is, it should have an octet structure. Which of the following is the correct Lewis structure for water? You have A. You can see it there. That is the structure, which is somehow linear. B. We have something like V shape. C. We have linear again, and D we have V shape. But the difference between B and D is B is having a single lone pair, where D is having what? 2 lone pairs. Therefore, the correct option in this case is letter D, in which the shape is V shape and there are 2 lone pairs of electrons. Now we also have double and triple covalent bonds, and then I'll explain this using nitrogen. Will be nitrogen, and here we have oxygen with what? 1, 2, 3, 4, 5, because this is the valence, plus another oxygen with 1, 2, 3, 4, 5, 6. Where is the valence? Huh? Now this will give us oxygen and oxygen. So this oxygen now will use 2 electrons here. This one also will bring what? 2. So this was having 4. Sorry, this one was having 6. We use 2 here now. It means we have 4 more. We'll have here 1, 2, 3, 4. And here, this atom also was having 6. We use 2 here. We have 1, 2, 3, 4 more. You can have here 1, 2, 3, and then 4. And at the end, if you count 1, 2, 3, 4, 5, 6, 7, 8 octet for this atom. 1, 2, 3, 4, 5, 6, 7, 8 octet for this atom. And this can be represented as oxygen single. That is double bond. You have this. So this is the bond exists in what? In oxygen gas. The nitrogen gas will have N 1, 2, 3, 4, 5 plus another N which is 1, 2, 3, 4, 5. And this will give us N and what? An N. So this is having what? 5 valence electron. But this N now will bring 1, 2, 3. You will have 2 more. Those 2 will come to this place as lone pairs. This one also will bring what? 1, 2, 3. The 2 that are left will what? Place here. 1, 2. So you see at the end we'll have 1, 2, 3, 4, 5, 6, 7, 8. For this is octet structure. 1, 2, 3, 4, 5, 6, 7, 8. We also what? Octet structure for the other atom of nitrogen. So here we can say N. These 2 will represent single bond. The other 2 represent single bond. And the last 2 will represent another single bond. We have this 2 electrons here, 2 electrons here. So these are the ways we represent double and triple bond respectively. Now we also have what? Bond length. That is, we have single bond, double bond, and also what? Triple bond. So you see, single bond is longer than what? Double bond. That is, single bond is longer than or greater than what? Double bonds. So double bonds also are greater than what? Triple what? Triple bonds. Which means again, triple bonds are stronger than what? Double bonds. And double bonds also are stronger than what? Than single bonds. This one is what? Length. And this one is what? Strength. Triple bond is stronger than double bond, and double bond is stronger than single bond. But single bond is greater, is longer than double bond, and double bond also is longer than what? Triple bond. Now we have a summary on this table where we have the bond length of different kind of molecules depending on the what? Number of bonds contained in this kind of molecules also. Now we have covalent bond energy. Now comparing oxygen gas and nitrogen gas, if you want to break these bonds, because we have triple bonds in this nitrogen gas, we need more energy in breaking this nitrogen molecule than what? In breaking the what? Oxygen molecule. Because we have more bonds in the what? Nitrogen molecule than the what? Oxygen molecule. So also, if you want to break also another molecule which is having single bond now, comparing to oxygen molecule now, the oxygen molecule also will be what? We will need more energy than in the other one where you have single bonds. So the greater the bond, the higher the what? Bond energy. Now, how many electrons are shared by 2 atoms to create a double bond? Which means 4 electrons. 4 electrons are shared, and then when 4 electrons are shared, we said each pair represents a single bond. Therefore, we have 2 pairs which also represent double bonds. How many electrons are shared by 2 atoms to create a triple bond? And the correct answer to this question is going to be 6 electrons, because a pair of electrons will represent a single bond. Therefore, we'll have 2, 2, 2. 2 times 3 will have 6. So therefore, the correct answer here is 6 electrons. As the number of bonds between a pair of atoms increases, the distance between the atoms will what? A. Increases. B. Decreases. C. Remains unchanged. And D. Varies depending on the atoms. Which means in this question now, the correct option here is letter B, which is decreases. As the number of bonds increases, the distance between them will start to what? Will start to decrease, because the bonds and the distance is inversely proportional. Now we also have the diatomic elements. This question. Now, 7 elements in the periodic table are always diatomic. In their elemental form, they are always seen as 2 atoms covalently bonded together. That is oxygen, that is hydrogen molecule, oxygen molecule, nitrogen molecule, chlorine molecule, bromine molecule, iodine molecule, and finally we have fluorine molecule. Which of these diatomic elements contains double bonds, which contain triple bonds? Now, we don't want to draw, or we don't want to go into details to draw all these things, but then the one with the double bond is going to be the what? The oxygen gas, that is the oxygen molecule, because we have seen the structure on this board. And the one which is having a triple bond is the nitrogen molecule, and then we have seen this structure on the board also. Now we have also coordinate covalent bonding. Coordinate covalent bonding. Now this coordinate covalent bonding now is a type of covalent bond in which the electron pair required for bonding is donated by what? One atom or a single atom. They will bond, and the bond will be covalent now. It's supposed to be shared of electron, but the electrons needed for this bonding now is provided or is given or is donated by a single what? Single atom. Now note, a dative bond is a true covalent bond. Yes, you cannot rule out this kind of bond from the what? Types of covalent bonds. 2. A dative bond is formed between an atom which is sort of a stable electron configuration by two electrons with an other which has a lone pair of what? Electrons to offer. If non-metal X and non-metal Y are to react, so this non-metal, which is X now, should have what? Lone pair of electrons that it can offer to the other what? Non-metal. And here also, this Y, that is non-metal Y, needs these two electrons, so it should have what? A vacant what? A vacant shell. So that when these lone pair electrons comes from the X to the Y now, it can be what? Attached to the what? Vacant shell. Now a dative bond is represented by an arrow pointing from the atom with the electron pair to the electron acceptor. We use an arrow to show this kind of what? Dative bonds. And then the examples we have in this case is ammonium ions and also hydronium ion. I can just include here coordinate covalent bond, and you want to draw this one, ammonium ion. Ammonium ion. Now this ammonium ion now involves what? Ammonia plus what? Hydrogen ion, and then this will give us what? The NH4 plus. You understand? Now from the covalent bond, if you understood how to draw this ammonia, that is the bond of ammonia now, we can simply react with what? With hydrogen ion to form the what? Ammonium ion. Now this ammonia now will be something like this. Nitrogen, we have here 1, 2, 3 atoms of hydrogen, and the lone pairs here, because nitrogen is having 5. So 2, 3, 4, 5. That completes what? Nitrogen. So hydrogen is having what? 1, 1, 1. But we have 3 atoms of hydrogen in this case. So therefore we'll have here 1, 2, 3 from the different kinds of what? Hydrogen atoms. Plus a cell which is vacant, which is sort of what? Electrons. This cell is not having any electron because it is what? Positively charged. It means the electron in this hydrogen is already what? Donated. That's why it is what? H plus. So this cell now is what? Is vacant. The cell is what? Empty. So in this case now, we can have something like what? Ammonium ion. So what will happen in this case now is you will have again something like this from this structure. We will have this, we will have this, and also we will have this. See? And then we are having what? Lone pairs of electron here. Now you see this vacant cell, this empty cell now will attach itself to this side. Do you understand? The nitrogen will what? Will invite the vacant cell from the what? From the hydrogen to attach itself here. And now the nitrogen will date the hydrogen using what? An arrow. So you see now, you circle these two electrons now, and then you put the arrow inside the what? Electron cloud, which means the nitrogen is dating the what? The hydrogen. And then we can simply represent this as N single bond with what? Hydrogen, that is this side up, and this side single bond with what? Hydrogen, and this side single bond with what? With hydrogen. This vacant cell is still from the what? Hydrogen ion. We still put there what? H, but then it was dated. Put this in the form of bracket now, because it was having a charge here. You still what? Put the charge there. From this one also, we still have what? Another charge in this case. Now we have factors that favor dative bond formation. So without these factors now, there will be what? No dative bond. 1. The presence of lone pair of what? Electrons leads to strong dative bond formation. That is, you see, this ammonia is reacting with what? With the hydrogen ion. And the hydrogen ion is not having any electron. So if this ammonia from the nitrogen, it was not having this lone pair of electron, so there will be what? No dative bond in this case. So there must be what? Lone pair of electrons, so that it will satisfy what? This vacant cell. The next thing is the presence of empty or vacant cell or vacant orbital leads to strong dative bond formation. See now, if this one also was not what? Empty, so this nitrogen now will not be able to what? Donate the electrons or donate these 2 electrons to the what? To the hydrogen. So in any kind of dative bond, there must be what? Presence of lone pair electrons and also presence of vacant cell. Other kind of bonds that are not dative, but then this kind of bonds, they are covalent. They are covalent. Maybe we just draw one radical, something like SO4 2 minus. SO4 2 minus. So here, sulfur and what? Oxygen. Of course, we have 4 atoms of what? Oxygen. The valency of sulfur is 6, and the valency of oxygen is what? 6 also. This is 4 atoms of what? Oxygen. In this case now, we will have one cell, and this cell now will represent what? Sulfur, because sulfur here is going to be the parent atom. We have 4 atoms of what? Oxygen. So which means one atom will attack itself here, another atom on this side, another atom on this side, and finally we have the 4th atom on this side. So when oxygen is bonding with other elements, it normally uses 2 electrons, because oxygen needs 2 to be stable. That's why it will give you 2, you bring 2, you share it, and then it will be stable. So in this case now, this oxygen atom now will use 1, 2, that's the oxygen, and the sulfur here will use 1, 2. So this oxygen will have 1, 2, 3, 4 more. And still now in this case, oxygen will bring 1, 2, and sulfur will bring 1, 2. So oxygen will have 1, 2, 3, 4. The sulfur is having 6. We use 2 here, which means we have what? Minus 4, which is going to be what? 2. So sulfur has 2 more electrons, and it still has to bond with what? These 2 atoms of oxygen. So there is no way for this sulfur. The sulfur now, we just what? Give 1 electron to this one, 1 electron to this one. As far as they are what? Bonding. And then we said in this covalent bond, at the center of electrons, this oxygen also will just bring what? 1 electron. So when oxygen bring here 4 atoms, it is having 6. You see here 1, you'll have 5 more. You'll have 1, 2, 3, 4, and 5. You have what? 5. This one also, oxygen also will bring what? A single electron. We'll have 1, 2, 3, 4, and then what? 5. Now if you count, you will have 1, 2, 3, 4, 5, 6, 7, 8. Which is what? Stable. 1, 2, 3, 4, 5, 6, 7, 8. Which is what? Stable. But in this case, we will have 1, 2, 3, 4, 5, 6, 7. So it needs what? 1 more to be what? Stable. We put here minus. 1, 2, 3, 4, 5, 6, 7. It still needs 1 more to be what? Stable. We still put there what? This minus. So now if you add this minus 1 and this minus 1, you end up having what? Minus 2. That's why the charge here is also what? Minus 2. We can represent this as sulfur, double bond oxygen. We have 1, 2, 3, 4. And also another double bond here. 1, 2. Here also we have a single bond, pair of electrons. 1, 2, 3, 4, 5. Single bond. 1, 2, 3, 4, 5. So we put here negative, we put here negative. At the end, if you add these 2 negative values, you will have what? Minus 2. This is why the charge of this radical now is minus 2. Now we have some questions to answer, and then the first question reads, how many valence electrons does CO3 2 minus have? How many valence electrons does CO3 2 minus have? Now here you have to draw the structure, that is you have CO3 2 minus, and carbon now will be the center here. You have 3 atoms of oxygen. One will come to this side, one will come to this side, and another one will come to this place. Carbon is having a valency of 4. That is, carbon and oxygen is having a valency of what? Of 6. So this carbon now will put 1, 2 here, and oxygen also will bring 1, 2. So this oxygen will have 1, 2, 3, 4. Here, the carbon uses 2. We have 2 more. So it will bring 1 here, 1 here. So this oxygen will bring 1. This oxygen also will bring 1. So oxygen will have here 5. Oxygen also will have here what? 5. So now the valence electron of carbon in this case now, or the valence electron of CO3 2 minus now would be what? 1, 2, 3, 4, 5, 6, 7, 8. So we'll have 8 as the correct answer in this case. We also have another one. How many valence electrons does H3O plus have? That is hydronium ion. Hydronium ion, that is H3O plus. In this case, you will have oxygen, and this oxygen will have something like what? You have 1, you have here H, you have here H, you also have here what? You have here something like what? H. So now, in this case now, this is going to be 2, 2, 2, 2. Now, also is going to be what? 8 electrons. 8 electrons. Now we have Lewis dot structures for what? For ions. Like that is the what? The dative bonding. And then we have talked about these things. So you can practice how to draw this hydronium ion, and also how to draw the trioxynitrate 5 ion. The same steps as this one. That is this polyatomic anion. Now again we have other options. Which of the following is the correct Lewis structure for ammonium ion? We have A, we have B, we also have C, and also we also have what? D. So the correct option here is letter B, because the Lewis structure of ammonium ion must constitute of what? A dative bond. Which of the following is the correct Lewis structure for sulfide ion? Sulfide ion. So here also in this case, the correct option here will be, you have letter A, letter B, letter C, and also letter D. So the correct option in the sulfide ion in this case now will be, none of these options are correct. None of them is able to explain the actual Lewis dot structure of sulfide ion. With this, we come to the end of this lesson, or we come to the end of this session today. So see you next time in our subsequent videos. So by the way, the coronavirus is pandemic. Coronavirus is contagious. So the best thing is to stay home and stay safe.
Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
In communication, connectivity is everything. We ensure that the links never sleep. Quantities and qualities, all in our data service, providing efficient, reliable voice and data service. We believe if you're not up to speed, then you're going backwards. Communications have to flow as fast as the speed of light. Whatever business you're in, having someone who understands your needs is critical. That is why we just don't offer you technology, we offer you solutions. Enjoy Gamcel's internet broadband anytime, anywhere. Your national operator, Gamcel, Yaibaram.
Agada.
Mbijan raganya.
Albaka.
Mbaka important.
Yo, nga transfer la sto.
Ya transfer la sto.
Ha, code nyingi.
Okay. Korsa. Nsila ID soto.
Ah, sa soto. Sorry. Agada.
Mbijan bro.
Albaka.
Mbaka.
Bara Allah service o tariya.
Ah,
mbare ki janna nun tariya.
Ah, janno mina forest de bureau. Gambia to konna no mbari ya kere. Ha. Birim koyna ko kato.
Bari si kodo kino kato nim fo bolong blabe to.
56 branches mola soto Gambia jam.
Ha?
Ha. Gambia kono ani Gambia bantala bankol. Nko kodo kiya bele. Kodo sifa ko falindiro ko nyaadi ta memena ko di topoto nin ko di maraw. Jannam mbo wandi nyonta. Andum fana nata anoda enterprise sotale. Wolam nyindi ko domorol fana ko fana be firale le dadi ma ni domorol ni fana beteat. Gambia dawda yalo ngam fa kendol sotale je.
Ha, wo mo yo diat ha.
Apelenta
baraka ba. Ni lafta nyelen kendol e bina.
Yalo bu kanyi la ko la baraka ba.
Yalo ndel chosano lo.
Abaraka.
When we touch down, better broke down.
Gamtel G-Fiber, now you can enjoy super fast internet in gigabytes. G-Fiber is affordable, stable, secured, and accessible to homes, businesses, and enterprises. With Gamtel G-Fiber, the future is speed. Gamtel, creating a brighter future in communication.
That's how she became mine and see that.
la domoro ka diatel
boy jannon CK's restaurant
sa na ko be ni na dimbal nimba domoro kala janno
domoro seneyata adiyata topotoro fanan kendema bije luntan during tamala abeka domoro ki janni adi manda wala de te ka we bijele anim fanan ka fadi jang ikono e fa e ka fa minne ko pastry anim bakery iko fanan be kalele badde lomba conference lomba workshop lomba ye fo fendin lon dunia kono domoro betama nyillom international o toda number 1
amanke ba domoro jandama
esa domo jang is atariya
wo mu kubandi
sa na ko sa futandin
oto sa na ko be mu CK's restaurant
ndafa na janna mu yat ni manje dorom bijam
aban
CK's restaurant, known for best quality food and customer satisfaction.
In communication, connectivity is everything. We ensure that the links never sleep. Quantities and qualities, all in our data service, providing efficient, reliable voice and data service. We believe if you're not up to speed, then you're going backwards. Communications have to flow as fast as the speed of light. Whatever business you're in, having someone who understands your needs is critical. That is why we just don't offer you technology, we offer you solutions. Enjoy Gamcel's internet broadband anytime, anywhere. Your national operator, Gamcel, Yaibaram.